Welcome to today's webinar. My name is Tyler Reid. I'm the Manufacturing Applications Manager here at GoEngineer, and today we are talking about CAMWorks. We're talking about the newest module from CAMWorks called Tolerance-Based Machining. This webinar shouldn't last too long. The tolerance-based machining portion is relatively simple to install. It's relatively simple to use, and it's going to be a pretty quick overview. Tolerance-based machining is going to allow us to use CAMWorks to program parts like you see here much quicker than we've been able to do in the past. So we can see we have a pretty complex part. It's an aerospace part. And in many industries, when we get drawings or when we get 3D models, they have complex tolerancing as part of them, either GD&T type of tolerancing or just simple symmetrical tolerancing on lengths and depths and holes and whatnot. When you're encountered with parts like this and you're doing the CAM programming, it complicates the CAM programming quite a bit. We see issues here with, say, asymmetrical pockets. How do we program that on the CAM side? Well, we have to adjust the offsets and basically machine to the mean. And this has all been done manually in the past. Now, with tolerance-based machining, or TBM, we can actually capture that data and use it alongside our technology database to automate a lot of this type of programming. This is part of a much bigger push within Dassault and within SOLIDWORKS to create 3D CAD models with all of the manufacturing data. SOLIDWORKS has a new module called MBD, or Model-Based Definition, that is a big push towards a movement away from 2D paper drawings and having all of the CAD data in the CAD model. And CAMWorks tolerance-based machining is going to be a huge complement to that. So tolerance-based machining, if you've used CAMWorks, this is going to make a lot of sense. If you're new to CAMWorks, you almost might just take this for granted and just have expected it to do this, but it hasn't done it in the past. And I should say, as far as I'm aware, CAMWorks is the only CAM product that handles this type of information currently. And not only in the SOLIDWORKS environment, but in every environment, the tolerancing data. So essentially what it does is it automates the selection of machining strategies based on standard SOLIDWORKS dimensions that include tolerancing, SOLIDWORKS DIM expert dimensions, and also SOLIDWORKS MBD data. Now, those dimensions can be things as simple as just symmetric plus or minus linear tolerances. They can also be asymmetric tolerances. So we're going to see an example here where maybe it's +0 minus 5 thousandths on the size of a pocket. What CAMWorks is going to do is machine to the mean. It's going to take the average of that tolerance, and it's going to make the pocket slightly smaller and try to hit the mean there. It also can handle depth tolerances on holes. Here's also something completely new, is with the addition of the TBM, automatic feature recognition is now going to find some 3-axis surfaces. So historically, the feature recognition only worked on 2-dimensional features, pockets, holes, slots, bosses, stuff like that. And anything that was going to be cut with a 3-axis toolpath had to be created manually. But now, if either the programmer or the design engineer calls out a surface finish on a particular face, CAMWorks is going to create a feature on that face and adjust the machining strategy based on that surface finish callout. So we're going to jump into the software, but first I wanted to cover where you download this. So TBM is available to all current CAMWorks users. It's not an additional module you have to purchase. You don't have to contact us to get access to it. You simply go to the website, camworks.com, and you're going to go to the standard download section. It's normally under support, customers area. You're going to go to CAMWorks downloads. And then right here under CAMWorks tolerance-based machining, you're going to be able to download the package here. And there's also an installation guide that might be worth opening up as well. But when you download this, it's just going to download a folder. It's going to look something like this. If you can see that, it just has 2 folders and an installer. Okay. To install it, you're going to run the installer. I definitely recommend right-clicking and saying Run as Administrator. That will install the software. Now, it's really quick. It's only going to take a few seconds or so. And then once you open up SOLIDWORKS and you have the CAMWorks add-in running, you will know it installed because under the CAMWorks Workflow tab, you'll see 2 extra buttons over here on the far right. You have tolerance-based machining with the user interface and tolerance-based machining without the user interface. So it just adds 2 buttons. And we're going to talk about what each of them do. But first, I want to talk about this part I have. This is one of the sample parts that gets installed. Going back to that folder quickly, one of the folders that gets downloaded is a sample parts folder. So you're going to have a range of parts. Some of them have DIM Expert data. Some of them just have standard SOLIDWORKS dimensional data. This particular one has DIM Expert data. You know it's DIM Expert because of the color of the dimensions. They're that magenta color. So right here, we see just 2 simple hole dimensions. They are symmetric, so they're plus or minus the same number. We also have something called a hole pattern. So over on this side, notice the 2x. This dimension applies to both holes. CAMWorks takes that into account. If you're not familiar with DIM Expert, we do have videos on our YouTube page covering how to create a DIM Expert dimension. Just real quick, there is a DIM Expert toolbar in the Command Manager. And in that toolbar, you can do location dimensions. You can do size dimensions, which is what we're normally going to be using alongside TBM. You can use a basic dimension, a pattern feature, which would be an example of a pattern feature would be my whole pattern in this triple tree part. And you can do datums and geometric tolerances. So right now, CAMWorks TBM interfaces with some of these types of dimensions and not others. Things like datums and geometric tolerances, there's no interaction with those yet. There's also a DIM Expert tab in the SOLIDWORKS feature tree. It's the crosshairs, and we can see our listing of DIM Expert dimensions within the current model. So we can see we have a simple hole here and a cylinder pattern here. So let's jump over to the CAMWorks Workflow tab and we'll take a quick look and see how TBM actually operates. So I'm going to click on the button that says Tolerance-Based Machining with the User Interface. That's going to give us something to look at. So this pop-up window is the user interface for TBM. What we see here is we see a chart with 3 columns. The first column lists all different types of features: holes, pockets, slots, bosses. Each one of those feature types also has the particular shape. So we have rectangular pockets, circular pockets, irregular pockets. We have a default strategy. So say for rectangular pocket, the default strategy is rough finish. And in the last column, we have tolerance-based conditions. We have 2 of them. So what that means is if we look down in this area, highlighted, these are our 2 conditions. We have a tolerance range, in this case, 0 to 0.002 tolerance, and then a corresponding strategy. So what this means is when CAMWorks runs the automatic feature recognition, it will find a rectangular pocket, for example. And if it finds a rectangular pocket with either DIM Expert tolerances or standard dimensions with tolerance data, if those tolerances, the full range of the tolerances fall within between 0 and 0.002, it's going to choose this strategy: roughed rest, so a second roughing pass, and then finish. If the tolerances are wider than 2 thousandths, it will simply do the rough finish. If we look at the hole option, holes have by default 3 conditions. The tightest tolerances, it's going to choose the bore strategy. The mid-range tolerances are going to choose the ream strategy. And then the most loose tolerances are going to choose just a standard drill strategy. Okay, so the idea of having strategies is not new. We always just chose them manually. Like we would run the feature recognition, it would find a hole, it would choose the default strategy, which is typically drill. And then as a machinist, we would have to say, you know what? My 2D drawing specifies this as being a tighter hole than what I can achieve with a drill. I'm going to make the decision to choose a bore strategy. TBM makes that decision for us. Now we can edit these. Okay, so just like the whole mantra of CAMWorks is that you can customize it. You can definitely customize this as well. If I highlight this cycle, I can change the tolerances ranges. I can also add more ranges. And when I add a range, it will allow me to choose a default strategy. Okay. The last thing within this user interface are just some checkboxes that are going to control how far ahead CAMWorks is going to move in an automated way. So when I press OK, since I have all these checkboxes run, it's going to do the automatic feature recognition. It's going to generate an operation plan, so it's going to run all of these features through the database. It's going to sort the operations, and it's also going to generate a toolpath. And then lastly, if there were situations where we had asymmetric tolerances, this box here, machine to the mean, will adjust the side allowances to machine to the mean of those asymmetric tolerances. So when I hit OK here, it's going to run the feature recognition. And it skipped all the way to the end till the point that we have toolpath. But if we go back to the feature tree, if you take a close look at the naming here, we have a hole group, which is the 2 holes for the fork stems, and also a tolerance range. So it picks up the tolerance range. It says an absolute value of 2 thousandths because we have plus or minus 1,000. And based on that, it selected a bore strategy. On this simple hole, it selected the ream strategy based on the tolerance of plus or minus 10 thousandths. So it automatically created the center drill for each of these holes, the drilling operation, and here's the boring cycle and the reaming cycle. So it saved me a lot of steps. It saved me from having to make the conscious decision of changing that strategy, or maybe I don't even change the strategy. Maybe I just manually start adding a bore cycle or a ream cycle. We're going to take a look at a couple more parts. This is also a sample part that gets installed. This one's a little bit different. Instead of just basic holes, we have some pockets. And these pockets have asymmetric tolerances. So the width on this pocket is 2.25 inches plus 30 thousandths minus 10 thousandths. This one's a little bit tighter. It's plus 2 thousandths minus 0. And this one is plus 5 minus 1. If I don't want to see the user interface, if I just want it to run with the defaults or whatever I have customized over time, I can click tolerance-based machining without the user interface. And this would essentially be the same as clicking automatic feature recognition. But consider any tolerances that are in the model. So let's take a look at the features it found. Did find that counterbore hole, and notice it just chose a standard drill cycle because there's no tolerance data associated with that feature. But when it came to the rectangular pockets, it chose the rough finish strategy for each one of them. So no difference in strategy. But if we take a look at, say, the contour mills, we can see tolerance mean minus 5 thousandths for this guy here. Tolerance mean minus 1,000th for that guy, and tolerance mean minus 5/10,000ths. And what that means is if we click into this, typically a contour mill would have a side allowance of 0. Okay, we would be machining the pocket to size. But because we have asymmetric tolerances, it actually adjusts that side allowance. Now it's set to minus 1,000th. So because the tolerance is giving you some room to make the pocket slightly larger, it's going to add a negative allowance. So it's actually going to overcut the model by a slight amount. It's going to average out that asymmetric tolerance and try to machine to the mean. By machining to the mean, it's going to give you the best chance of getting a part off your machine that hits all of the manufacturing requirements. It's going to eliminate a lot of scrap. It's going to eliminate a lot of parts that come off your machine out of spec. Now, if you are accustomed to taking 2D drawings, looking at some of these dimensions and adjusting your CAM strategies based on them, you're probably already getting good parts off your machine, but it's taking a lot of work and a lot of mental decisions to get to that point. And TBM is going to automate that. There's really no reason, if you're dealing with dimensioned models, to not use the TBM. Let's take a look at something a little bit more complex as a final part. I showed a screenshot of this part, and I thought it was a great part because it's a mess. There's so many dimensions here. A lot of them are asymmetric. Some of them are depth dimensions, like you see here. Some of them are hole patterns or pocket patterns. Notice this one, if I can get it zoomed in here. 4x, it's got a asymmetric tolerance on the width, and it has an asymmetric tolerance on the length as well. So very complex stuff. Take a look at these tapped holes. We have 20 of them, 3/816 UNC 1B. So there's a tolerance there, and then some tolerance on the depth. Lots of manufacturing data. So this is a very well-documented part. CAMWorks tolerance-based machining is going to make programming this a breeze. I should say programming it correctly a breeze. So I'm going to go ahead and run this without the UI again. This might take a minute because there's lots of features. There's lots of different setups in this. It's chugging along. It found the features at this point. Now it's running them through the database and it's selecting feature strategies. So now it's applying the machine to the mean. So now it's looking at all of the asymmetric tolerances on there, and it's doing the calculations to figure out what side allowances do we need on our finished passes. All right, and now it's got past that point. We're generating some toolpath. We're on the final stretch here. There we go. Look at all that toolpath. All right, so going back to the feature tree, it found 7 different setups. It found features that didn't have tolerance data, say like these pockets. And it found plenty of features that do have tolerance data as well. It ran all of those through the database. In situations where it had tolerance data, it adjusted the strategy selected based on that tolerance data. And in situations where they were going to machine to the mean, it did all of that as well. So if we run a quick simulation here, notice the stock is actually set up as just a non-standard stock piece. This is referencing a SOLIDWORKS configuration within the same part. Look at that. So, depending on how robust my database is, I honestly got to this point with one click. It's pretty impressive. Now, I would still run this simulation. I'm going to be double checking for things like tool clearance, shank clearance, holder clearance. I might go through and double check the sorting that went on, the sorting step. And now that it is done simulating, when I run the comparison tool, we can actually see, according to the comparison, some of these are overcut, some of them are undercut based on that side allowance that had to be calculated. A lot of the holes are overcut because they're all tapped, and so we're going to be removing more material than was modeled out. The most difficult part about using TBM is probably going to be either you yourself adding the dimensional data or convincing your design engineers to add it to their 3D model. Many design engineers are accustomed to only adding this data once it gets to the 2D drawing stage. It's definitely best practice to do it in the model stage. You're going to get better connectivity with the model. It's going to make creating the drawing itself much simpler, and it's going to mean that the 3D CAD model that gets passed to the machinist contains all the information, and nothing's going to be left up to the interpretation of the drawing. I think we've probably all seen drawings that are so crowded, very difficult to interpret, and possibly contains too much data. It's over-constrained. By putting these tolerances in the 3D model, it eliminates a lot of that. So I promise this is going to be short and sweet. That's about all I have to cover on the TBM. We covered where to download it, how to install it, the user interface and how to run it, which is essentially not much more complicated than just running the standard automatic feature recognition. We discussed briefly how to edit it. And if you want more information on how to actually add the DIM Expert tools, I recommend going to our YouTube page. You see it listed there, youtube.com/GoEngineer, and simply searching for DIM Expert. And you're going to find a great introductory video. You can also email me directly with questions at treid@goengineer.com. Thank you guys for joining me on this quick webinar. If you have any questions, please let me know, and I will catch you next time.